Hi guys, and welcome to this other video. Hope you all are doing well. So in this video today we are going to talk about FortiGate IPSec VPNs. So during this video we will show how it works, IPSec negotiation phases, VPN topology, and the deployment state. Then we'll go on the practical. So here is the scenario of the practical that we are going to do. So here we are going to have uh, two remote sites, one in Paris and the other one FortiGate in Paris and the other one in Tokyo. So we'll see how to establish an IPsec tunnel between the two firewalls so that someone or a workstation from the Paris subnet here will be able to join the subnet that is in the other part in Tokyo. So before jumping into the deployment, let's quickly explain some key concept of IPsec tunnels. So what is IPsec VPN tunnel? So this is uh, a way of creating a secure and encrypted tunnel between two remote networks over an untrusted network such as internet. So how it works is you initiate the encrypted tunnels configuration from each firewall. So a negotiation phases will will occur. So we have two negotiation phases, phase one and phase two. So during the negotiation phases, so the two sides are going to negotiate the security parameters that will be used during to establish the secure tunnel. So once that is done, the encapsulation will follow. So there will be some security parameters that will be exchanged, some data that will be exchanged mainly during the phase one. So we'll discuss this in the next slide. So after this, the two firewalls will need to authenticate. So authentication will be done either through a pre-share key or either through a digital certificate. So this will be used by remote users and site to authenticate on each device. So after all this is established, to let traffic go through, we need to establish or to set up firewall policies to let the traffic go through. So talking about negotiation phases, so as we said, we have two phases. So in the phase one is to authenticate the IPsec peers so that we can create a secure encrypted channel for the phase two negotiation. So before phase two is initiated, phase one needs to be completed. So during phase one, the two endpoints through their gateway will exchange credentials and identify each other and negotiate a common set of policies. So the policies will be like, okay, I would like us to use this encryption protocol. He will say, I would like us to use this algorithm. So the two ends will exchange the information, and if all is good, the phase one will be established. Then when phase one is established, now we will go on to phase two. So the phase two, the purpose of the phase two is to negotiate the security parameters for the traffic or the data traffic that will be going through the VPN tunnel. So in phase one, we exchange credentials to identify each other, and in phase two, they will negotiate the security parameters for the data traffic over the VPN tunnel. So in phase two, the endpoints using their secure channel created in phase one, they will negotiate parameters for protecting and encrypting the data that will be going through. So this is done through what we call phase two selectors. So the selectors here, you can create one, two, or more security phase two selectors. So the selectors or the security association are created to define how the actual user data will be encrypted and authenticated. So you need to define what is the local network that you want to let traffic go through in the IPsec tunnel, and you also define what is going to be the remote location, remote subnet. So when all phase one and phase two is completed, now the tunnel is established and communication can now be done between the two sites. So talking about VPN topology, depending on the size of your network or your company, you might have one of these topologies. So either you have just a simple topology where you have a headquarter and a branch office. So you just want to establish an IPsec tunnel between the two so that data can be exchanged on both sides or from one side to another, depending on how you like to do it. So this is a basic topology. But if you have multiple branch offices, in that case, you might need to be in this topology where you'll be in hub and spoke, where you have a central headquarter, and you need to configure IPSec tunnels between the headquarter and each branch. So in this case, the headquarter is the central point where all traffic will need to be routed, so that so traffic will be routed through the central headquarter firewall. Traffic that is going from one branch to another needs to pass through the headquarters FortiGate. So the inconvenience of this is that if the headquarters firewall have some issues, there will be no more communication between all the branch offices. So no communication between no exchange of communication between branch offices. So that's why in some companies, depending on the size, you might also use what is also called as a mesh topology. A mesh topology where each branch office has a direct connection with all the others, the other branch offices. So like from this image here, you have this office will have a connection directly from here. This one also have a connection from here. So each branch office will have a direct connection with the other branch offices. The inconvenience here is that the FortiGates need to be, the FortiGate will be resource intensive. You need to make sure your FortiGate have much resources to support the traffic, because you'll be configuring multiple faces for multiple IPsec tunnels. So you need to pay attention to that. So talking about the deployment steps, so from each FortiGate, you will need to initiate the IPsec tunnel. So you need to know the remote device type. Is it all two devices, are there both FortiGates, or maybe you are configuring between a FortiGate device and a Cisco, a WatchGuard. So you need to know both remote gateway. You need to define, are you using a pre-share key or you are using digital certificates. You need to choose the encryption and authentication algorithms that you are going to use. So you make sure the encryption and authentication algorithms are both supported on both endpoints. So you also need to to identify the local and the remote subnet that you are going to create on the phase 2. So after this is initiated, you need to create static route. Then you create firewall rules for outbound traffic and inbound traffic. So if you want to have traffic on both sides, both directions, you need to create two firewall rules. So from the client's workstation, if a client is directly connected to one of the subnets that you decided to include in the phase 2, so there is nothing for that user to do on his workstation. Once the tunnel is established between both devices, both FortiGate devices, in that case, the user can directly send requests to the remote subnet. But if the user is a remote user, so he will need normally to connect through VPN. You need to use FortiClient VPN to connect to one location, so that from that location he can get access to the other location. So we have another video on the channel where we describe how to configure SSL VPN. So here is the practical the diagram that we are going to use. We have this FortiGate in Paris. We have a subnet of 10.1.10.0 /24. This local network, we are going to establish an IPsec tunnel between these two firewalls, so that someone on this subnet can access resources on this other subnet and vice versa. So let's jump directly to the Paris firewall. So on the Paris side, what we need to do is go under VPN, IPsec tunnels, create new IPsec tunnel, custom tunnel. I will set tunnel to Tokyo. I'll say it like this. name it like this. Next. So here I'll provide the gateway to access the FortiGate that is on the remote site. So the Tokyo 192.168.2.109. So I know this through this port on this firewall. So here you have another settings that you can configure here on the for the tunnel. For the sake of this video, we're not going to go in details. So here we go under authentication. You can go either with the pre-shared key or a signature or digital certificate. So we go in the pre-shared key. So the same pre-shared key that I entered here, the same value that I enter here, I'll enter it on the remote FortiGate. So for the IKE key exchange protocol, I'm going to use the most common or the most used version, so version 1. So here on phase 1 proposal, we are going to select the encryption and authentication algorithms that we are going to use for this phase 1. So I'll just go with this one. So here below under phase 2 selectors, here is where we need to configure selectors. So we are either configuring just one selector or multiple selectors. So the selectors here is where you need to bind a local subnet that you have on this FortiGate to a remote subnet that is on the other FortiGate. So if on this FortiGate, if I have like 5 subnets that I want to share, so I'll create like 5 selectors here. So here I have just one. So here the local subnet that I have here is 10.1.10.0/24, and the remote that is on the other side for Tokyo is 172.16.20.0/24. So this is the only selector that we are creating here because these are the only subnet that we have on both sides. So I'll say okay. So now we need to create a static route to route the traffic to the destination subnet. So destination subnet is this one. So to go to the destination subnet, we need to pass through the IPSec tunnel that we created. So we say okay. So next we will go under firewall policies. So before we create the policies, I'll go under addresses. So under addresses, I'm going to create two objects. So the first one I'll call it local network. Let's say it like this, local network. So the local network on this firewall is 10.1.10.0/24. Then I'll create another firewall, another address object. I'll call this Tokyo network. So it is going to be the Tokyo network object 172.168.20.0/24. Hit okay. So now we go under firewall policies. So I'll create new firewall policy. Here I'll call this Paris to Tokyo. Call it like this. Incoming interface is the internal network, interface, the interface that is directly connected to the local network. So the outgoing interface is going to be our IPSec tunnel. Then the source is going to be the subnets, the local network subject. So local network that we with the object that we created earlier, and the destination is going to be the remote subnet, so the Tokyo network. Okay, so from here, services, for the sake of this video, we're going with all. NAT is not needed. Then here we'll go with all sessions. Then so here we are creating a firewall policy to allow traffic from the internal network to the Tokyo network going through the tunnel that we create, IPSec tunnel that we created. So I hit OK. So now I also need to allow traffic from the other side, so from Tokyo to enter our local network. So what I'm going to do here is I right click on this firewall policy, then I'll go on clone and reverse. So this will duplicate this firewall policy, but it will reverse or inverse the source and destination. So I'll hit clone. So if you pay attention here, you will see that for the two firewall policies, the source for one is the destination, source for one is destination for the other. So here I'll just edit this one. to provide a name. So I'll call this one Tokyo to Paris. Hit apply. Okay, this is done. So always remember to enable when you do the reverse or the clone reverse. Always need to manually enable the policy. So from this firewall, I think all is set. So the IPSec tunnel is initiated, firewall policies are created, the static route is also created. So all we need to do now is to jump on the remote firewall, then proceed the same. So here on the remote firewall, what I will be doing is same thing. So I'll go here under IPSec tunnel, create new, custom tunnel to Paris. Next, so here the remote gateway to join the Paris network is this one. So through this interface, so here I'll provide the same pre-shared key that I set in the other firewall. Phase one proposal, yeah, we're going with this one. Delete this order. So here for the phase two selector, so the local IP here or the local subnet that we want to populate here is this one, and the remote on the other firewall is this other subnet. So hit OK. Now we go under network, static route, new route to this subnet should be going through this interface through the IPSec tunnel. Okay, hit OK. Now we go under policy and object. We go under addresses. I'll do same like the other firewall. So I'll create here also a local network address object. So local here is 172.168.20.0/24, and another one for the destination or the remote. So the remote network is the Paris network. So I'll just call it like this, Paris network, which is 10.1.10.0.24. Hit OK. So now I'll go under firewall policy. So from here I'll create new firewall policy. So I'll call this one Tokyo to Paris. So the incoming interface is this internal network. The outgoing is our IPSec tunnel. So the source here is going to be the local network, and the destination is going to be the the Paris network. So for services, same, we say all, no NAT, all sessions. Okay, so we'll do the same here, clone reverse. Then from here I'll just enable this. So hit I'll call this Paris to Tokyo. I'll hit apply. So from here I'll also need to enable this for this policy. So normally when I'll just hit enable on this policy, I think the IPSec tunnels will engage. So I'll hit enable. So as this is enabled now, so we'll just jump on the topology. So from here I'll try from this workstation, just check if config. So IP is .10. So on this other one, just double check so that I can send a ping if config. So this one is also 20.10. So from this firewall, so from this Paris subnet, I'm going to send a ping to 172.16.20.10. Hit OK. Okay, so now the traffic is going. So just go back to on the firewall policy. So on the IPSec tunnel, so now you see the traffic, the tunnel is up. So if you go under firewall policies, okay, we can see that the firewall policies. So now actually traffic is ongoing on the Paris to Tokyo firewall. firewall policies. It's letting traffic go. So for now, we have no traffic under Tokyo to Paris. This is because for now we have initiated a ping only from Paris to Tokyo. So let's jump on the Tokyo's firewall, then on Tokyo's workstation, and send a ping to the Paris side. So if I hit ping 10.1.10.10, so traffic is not also going from Tokyo to Paris. So if I refresh from here, yeah, okay. So now you also see traffic that is going on this firewall policy. So if I go, we can also do some monitoring under dashboard, network, IPSec widget. So expand. So from here we see our tunnel that is up, tunnel to Paris that is up. So we see we are having incoming data, outgoing data. Phase 1 is up, phase 2 also. So if I right click here, I can bring down this entire tunnel, or I can bring down just some phase 2 selectors. But pay attention that if you bring down the phase 2, or you bring down the entire tunnel down from here, if the ping are still ongoing, then the tunnel will not go down. So you need to pay attention on this. So this sometimes was so tricky. Some people did not understand. People in their infra, they were trying to put the firewall or the IPsec tunnel down, but there was a ping that was also ongoing. So as the ping keeps going, the tunnel will keep being alive. So if you need to put down the IPsec tunnel, what you need to do first is to hold on or stop the ping sessions. So we can try. See, if we go here, for example, if we do IPsec, bring the entire tunnel down. So I hit OK. So you see the tunnel is not going down, it's still showing up. Although we are saying entire tunnel go down, it is still showing up. This is because we still have pings that are actually ongoing. So let's say if I stop this ping on both sides. So now if I say bring down entire tunnel, hit OK. So now you see the tunnel is down. You see, now the tunnel is down. So you need to pay attention. So just check. If I go again and I recall again this ping, you see the ping is now going again. So when the pings begin, it will automatically bring up the tunnel. So if I just hit like actualize, refresh here, you will see that if I go again here, you will see the IPsec tunnel is up. So just sending a ping will bring alive an IPsec tunnel that was brought down. So good to know. Also pay attention that when you need to disable the IPsec tunnel, the key part to disabling the IPsec tunnel is through the IPsec firewall, under firewall policies. So normally if you want to prevent traffic from going from one side to the other, the best way is to prevent traffic directly from the firewall policies. So from here, you just right click the firewall, the corresponding firewall policy, then you just do disable. So in this case, even if the IPsec tunnels is down, it is not it will not prevent traffic from going. It will not prevent traffic if someone just initiate a connection to the remote site. So pay attention that when the tunnel is down, if anybody from one of the location initiate a connection to the other location, the tunnel will become alive and the traffic will go on. So the best way to block traffic is going through firewall policy. So like let's try again from here. So if I initiate a ping session from here, and also from the other location. So we see that traffic from Paris to Tokyo is not going through, but traffic from Tokyo to Paris is actually ongoing. So if we go on the firewall, you will see that from here, from the firewall policy interface here, you will see that there is no traffic received here because the firewall policy is disabled. But actually, we have traffic from Tokyo to Paris, and here under IPSec, you see that the IPSec tunnel is up because a ping is actually ongoing. So you need to pay attention on this when you are putting in place your IPSec tunnels, and when you need to disable traffic from one subnet to another. You need to pay attention on this. Either you are disabling the entire tunnel here, or you are either you are bringing down the entire tunnel, or you are bringing down some selectors. Even though you bring down some selectors, as we define selectors to be the association between a local subnet and the remote subnet, you can bring down the selector here. But if you want to deny traffic from going from one subnet to another, you should ideally come and do it under firewall policy. So hope you will pay attention on that while doing your IPSec tunnel configuration. Let me just show matching logs. So here, from here, you can also see logs that are related to the IPSec tunnels. So you can see what are the negotiations that have been done, what is actually the current state of your FortiGate IPSec tunnels. So guys, I hope this video was interesting. Let us know if you have any question in the comment section so that we can provide some answers. See you.